Okay, recording started. Okay. So this is your get height, right? So this is a recursive solution, right? So basically, what did you do? You had a root, right? Let's say you have your 10. You have 1, 2, 3, 4, 5. Similarly, 2, 3, 4, 5. So basically, what you did, basically what you do with using this method is you basically do DFS, right? You guys understand DFS? Shiji, Kamesh?
Yeah, yes.
What is that?
DFS, depth first search.
Search.
Yeah. I was there.
So basically, you first go as deep as possible for your left hand side. So basically, you go at 1, then you go to 2. Now, since there's no left over here, you go right. Then 3, you go 4. Then you go here, right? And then you go back here, and then you try 2, then 3, then 4. Then you go back up, and then you try the 5. So this is depth first search.
Right.
Clear? So Shiji, so this is DFS. Can you? I want you or all like everyone like. Can we do this BFS? And be like using breadth first search. Do you guys know what breadth first search is?
Yes. First it will go.
Yeah, Shiji.
Yeah, first go through all the nodes in that particular same height and then go down
Go
deeper.
to the next step. The next step.
Yes. So okay. So you say okay. So this is 10. You're saying you go to this level and then you go to this level and
Yeah.
then you go to this level. So I want you to code this up. So let's say you're given this function, get height, and you're given the root. So can you help me write the code for using queues using BFS? So if root is none, return 0. So this is so I just want to see if you know any pattern or some code that you know how to do this. Do you know, CG?
I'm just thinking.
Yeah. So have you done BFS before? Like have you implemented BFS before on a binary tree?
Yeah, I've done long back. Now I have to refresh everything.
And Kamesh, you also.
Right. So you're talking about BFS. You want me to get the height of the root?
Height of the tree. So basically, height here is
Yeah. Height.
height means number of edges to the deepest leaf. So here this is
Okay.
1, 2, 3, 4, 5. So there are 5, right? So height is 5.
The maximum height you're trying to look for?
Yeah. So basically the height of the tree. So basically
Okay.
your leaf till the root. The number of edges between the root and the leaf. That is your
Okay.
height.
Okay.
Okay.
So
Before I do this, I mean, CG and Kami, did you get an idea how to do this? Any idea? Or if you want, I can take a simpler example. One step back for using BFS.
yeah,
Yeah, that
please
will.
go ahead.
Yeah, Kamesh, what did you say?
Yeah. Go ahead. Go ahead, Ankur.
Okay. So this is also a question to you guys only. Let's say I'll give you the tree again. Let's say this is 10, 2, 3, 4, 5, 1, 2, 3. Let's say this is 8. Okay. So what I want you guys to return is so sum all the nodes. Basically just sum all the nodes. Okay, just sum all the nodes and return the sum. Is that something you can do using BFS?
Right. Um. Okay.
Yes. So if root is null, return 0. Fine. After that, what?
After the root, so if you are going to use BFS, then we will have to check the next level of first check its children. Get the children, root's children, and check the immediate children's nodes value and add it to it.
So how do you code that? Just tell me that code.
Okay.
Siji, do you remember any code? Like how would you do that? I know that you go to the root, you go to the children, you go to the children, you go to the children. How do you code it? This is something that you have to. This is something that has to be in your mind. Like you have to always remember. Like I did this question 2 years back. I still remember how to even start this question.
Okay.
I wish Arya was here today because she was there in the session yesterday also.
One second, uncle.
Yeah. Shiji, you want to try? Do you have an idea? So sum is 10 plus 1 plus 2 plus 2 plus 3 plus 8 plus 3 plus 4 plus 2 plus 5. So whatever the sum is.
Right. Well, just give me 1 second. Just give me 1 second.
Okay, Shiji, do you want to do this DFS first? DFS will be easy, right?
DFS will go the post order traversal, right?
So tell me that code.
First go to the left child, so take the value on the left node, the right node.
Left node? What do you mean by left node? Right node?
Okay, so each node we have to go till the end, right? And then come back and get the root, go to the right, then go to the parent node, go to the its parent, and then.
So what did we do for get height? So I gave this here, right? What was this doing? This is also same DFS, right?
Yeah.
So what was this doing? So let's say I'm at 10. What is this? What is this supposed to return?
So it will go to 1 to 8. 8 plus 2 is 10, 11, 14.
So this returns what? 14.
14, then add 10.
And this returns 2 plus 5 plus 3 plus 4.
Yeah.
Right? And then 14 plus 10 plus whatever this is, 7, 14. Right? So answer is 14 plus 14 plus 10. Okay. So that is your DFS, a post order. So what did you do here? This is the same as get height. Right. So what do you do here?
So sum of left node, then sum of right node plus the value on the root node.
So Kamesh, is this clear?
Yeah, go ahead. I'm just following.
Okay. So that's all. This is DFS. DFS or let's go, or yesterday we called it post order traversal. That's all. Is this clear what happened? Vijay, is this right?
One condition, base case, you have to put
if root is null, it's 0.
Yeah, that's it.
Yeah, that I told him. Yeah.
That's it.
Yes.
Yeah, this is the correct actually.
Yeah.
If you see, right, I mean, I don't know, he is doing a recursion, right? If you guys are familiar with a recursion.
That is what we did yesterday, right? Recursion.
Yeah.
But see, how it works in that recursion, we need to understand properly.
See, like very simple, right? Think in this way. Whenever you are doing recursion, whatever the value you are passing to the function or a method, that is a new value. Okay, these things you need to draw the graph. What happening here is a very high level. You think that in the root is 14, right? Assuming that the children, left children is 2, right children is 10, right? You want to add those 3 elements. What happens? 14 plus 10 plus 2, right? That's the answer, right? What we are doing, we are recursion is always about base condition. Until it reaches that condition, it doesn't trigger, right? Now you're passing like a 14, you already have a root, right? Now if you go into the left, right, for left sum, you are passing 2, right?
Yeah.
You are passing to the function 2. Now it will call to the left function. Left means the sum function. Now what happens? Again it will come back. Free dot left, right? Left is null, right?
Yeah.
Some
But
function
didn't
you
I
pass.
explain this yesterday? This is how to how to do post order. You're doing this, you're doing this, you're returning something back. And the only thing that in that yesterday's question was there was one more line over here which was updating the global variable.
Yes, but I think Vijay was explaining the recursion step one more time, how we should approach recursion.
Okay. Then we are sorry. Go ahead.
Yeah. See, until it reaches null condition, this function is not going to execute. What that means is internally it builds the stack, right? What happens once it reaches null? Then immediately it will call the previous function, previous whatever is there in the memory, right? That time what it has a 2. It returns 2, right? Like that, it keep building the stuff. It is like this. I didn't explain about the right how it will go, but assuming that it is only one condition, until it reaches null function, null, whatever the null value or base condition, it will go up to there. From then, it basically what happens is recursion is nothing but a stack. Okay, it builds the stack, right? Stack means you have a plates, right? If you go to the restaurant, right, you have plates, one plate on the top of that, right? What happens? Each function is going to build one top of that. It called stack frames. Okay. Once it reaches the top, right? Once the base reaches the base condition, you are returning 0, right? For that function, the value is 0. Now what happening? Previous condition, you are passing that value to 0, then value is 2. Like that, it will keep building 0 plus 2, like that. Basically, you are keep on getting the value. Like that, it will rotate it. Assuming like this, you are building the stack. Once it reaches the null condition or a base condition, it will do it. Then it will go to the, it will take away that plate. Then it will go and execute next plate. Next plate is 2, right? Now it is going to return 0 plus 2 is the value. But before even returning, then it has to execute, right? Next function is going to be right. It will go to the right and then it will give like that. It will keep building the stuff. The order will be little different, but I'm explaining you that first it executes until it reaches null. Null value is equivalent to 0. Once it returns 0, then 0 plus 2 will be 2. Then 2 is written. Then you are going with the right function, right? Right as a 10. You adding those things, and then finally you have a value, root value is 14, left is 2, right is 14. Basically, you sum up all these things, you get a value.
So in the stack first it will be 14, then it will be 2 on top of that.
No. Stack on the top is null, 0.
Okay.
Basically, what that means is every function call it is going to put in the stack frame. How you call, right? The sequence is same. Then slowly one frame will go away, then it will go to next frame, then it will go like that. You
so
think
in this,
like
so in this DFS, which Ankur has written the first one with 10, 1, 2. So first to come, if we are doing the DFS, it will come. It will be putting 10 on the stack frame first, then 1, 2, 8. Then it will reach us the null. Then it will be taking out 8, 2, 1 backwards.
What Ankur do with one thing, okay? Put a stack, one pipe one whatever we called
Can we do BFS first?
yeah, BFS do then, otherwise yeah.
Yeah, sure.
Or
But yeah.
okay, so let me see if we can. Okay, let me see. This is 2. This is 10. This is 10. I'll finish this fast. 3, 4. This, right? So this is your tree, right? So what DFS Vijay is explaining is yeah. So Vijay, you are explaining, right?
Mm-hmm. Okay, what I'm trying to say is this problem, if you want to understand, you need to understand like a stack, right? For the stack, first you are going to put in the 14, right? Put a 14. Then you are going to put 2, right?
Mhm.
Then you are going to put 3.
Mhm.
Then you are going to put 4, right?
Then it will
Now-
be null, right? After 3, it will go to null, right? And then only 4.
Now what you can go right or left, right? What happens is when you are traversing, you can go left, right, whatever the fashion. For just I'm giving idea, right?
Actually,
Now-
there won't be a 4 over here. Actually, there won't be a 4 here. So basically, you go to 14, you go to 2, right? Then you go to 3, right? And then you calculate 3. It returns 3. It pops out. So basically, this is a function, right? This is a function. You call function on this node. This will execute. This will get executed. It will put back, right? So it will return 3, and then this function will get executed, right? And then this will add 4 on top of it. Okay, so this is the step. Okay, first 14, then 2, then 3, then it will see, okay, 3 and 4, 3 has no left and right, so it will execute 3, it will hold the value, then it will go back to 2, it will go to the next step, it will execute 4, it will see there is no 3 and it has no left and right, so it will return back to 2. Now 2 will get executed, right? So now 2 has 2 nodes, one returns 3, one returns 4, so this will get popped out, then it will come back to 14, right? When it goes back to 14, then this will start 10 now, this one. So basically, when this is a function, right? At each function, it also storing some variables.
Okay.
That is what you're saying, Vijay, right?
Yeah, you are right. Exactly right. I was just trying to explain for them to easy to understand simple values, just like how the pop-up will happen. Just I was trying to explain that one. Yeah,
So basically, first it calls your 14, right? It calls your 14. So there are 2 variables over here. So when this is 14 executed, it will call one more method, right? It will call this method, the method for two nodes, and then while executing 2, it will put 3 on the stack, right? And now this will get executed. Now this will come out of the stack. Then for 2, then it will start with 4. 4 will come, and then this will be stored into this code. Then 2 plus 3 plus this one will get executed. This will go out, and then it will go and execute the right one. Till now, the right path is not there in the stack till now. See, because this is your function, right? You started with here, you went here, right? So so this is root dot left, which is 2. So right now, and once you go to 2, this will go into this will be placed into the stack. Sorry, when you call tree root, 14 is into the stack. Now when tree sum is called, now this is 2, this will call 3. Now 2 is into the stack, right? Now when 3 is called, it will again go here. It will call tree sum. Now 3 is on this will be on the stack. Then it will go here. It will return 0, right? This will return 0, and this will return left plus right plus root dot value back to 2. and then when it returns to 2, it will calculate 3, it will calculate 4, and then it will return its value back to 14. And then, so this is done, then it will come to the right tree. So that is how stacks work.
Okay, thanks.
So here also in DFS, right, stacks are basically, it's nothing but your DFS only. So okay, forget that, maybe we'll cover that later. But right now, okay, wait, who has come? Sulochana. Thank God, one more person joined. Hey Sulochana, Sue.
Hey, Ankur.
Change your name because this is being recorded.
Yeah, I have to change after logging in. So yeah,
Ah,
I changed it.
okay,
I cannot change before.
okay. So how was your onsite?
Yeah, it didn't go well.
It didn't go well.
Yeah,
Why?
partly because the interview, I felt honestly, the interviewers themselves sounded very confused. The quality of the interview wasn't great.
Oh, okay.
Yeah, yesterday's I didn't do, I mean, on the Wednesdays when I didn't do so well. It's recorded. Okay.
Sorry, say again. Day before yesterday, you didn't do well. So.
Maybe you have to. Maybe we don't want to record that now.
Yeah.
Oh, okay, okay, okay.
Recording after that.
Okay. So basically, okay, you were not there in the yesterday session. So okay, so we are starting fresh. We are actually starting binary trees,
Okay.
and right, and I'm starting this also. I mean, basically, you and Vijay both know how to do this, right? So basically, this is a question again, CG, for you only. We'll go into the DFS again, but the question is, you are given a tree, right? And one is, I asked them to find out the tree sum, like sum up all the nodes, and ask them to do it in DFS way. So this is one way, right? By using recursion, right, Sue?
Yeah.
So basically, I calculate the sum of the left tree, I calculate the sum of the right tree, and then I return left sum plus right sum plus right rooted value.
Yeah.
Now my question actually was, how would you do in BFS, like using queues? So that was a question to CG.
Okay.
So CG, you want to try that, or should I go ahead with the solution?
Yeah, you can try. Go ahead with the suggestion. I'll just catch up.
I can give it a try.
Yeah, try what you're giving on-sites. I expect you to do this. Okay, go ahead.
No, I just started like I'm giving on-sites with the companies that are least preference to me, because I started my preparation only in November.
Oh, okay. Okay, go ahead.
Yeah.
Then do this. Okay, then it's a mock interview for you then.
Yeah. Can you draw a tree for me?
This is the
I
tree.
cannot. Do you want me to log into the Scribble Together board?
Your wish. Either you want, so you can see screen share, right, properly.
Yeah, I can see the screen and can tell what the way to go about it for BFS.
Yes, either it's your wish. If you can see this and tell me code, I'll write it. Or you can
Okay.
go to Scribble, or you can, but I don't think
Yeah,
you'll
I'll
be able
just
to write
tell
easily.
orally. Yeah, so the BFS always starts with a queue. So to the queue we add the root, and while
So this is Python.
no Java.
Oh, okay.
But I'm telling it orally, like the steps
Okay,
that
okay.
have to be
Yeah.
followed. So we'll
Yeah.
we'll create a queue. We'll add a root value to the queue, and yeah, we'll iterate over the queue while queue is not empty. Pop the element from the queue. Pop the element from the queue, and outside this loop you will initialize a sum variable called sum, and then sum equal to sum plus the whatever node you popped out, node dot value. And then if while if node dot left not equals to null, add node dot left to queue. If node dot right is not equals to null, add node dot right to the queue. And yeah.
So CG, did you understand this one?
So this is a template we can follow for like
Yeah,
the
yes,
logic
yes.
will change, but the queue approach is what we go for all BFS and then return sum. Yeah.
So do you want me to go with this? So did you follow this?
Yeah, yes, understood. I remember. I remember now what I had done this before, but forgot. But now I am able to recollect what I learned earlier.
Right. So basically, this is your this is the most basic template.
Mhm.
And Sue, do you want to give the time complexity and the space complexity for this?
Yeah. Yeah. Time complexity will be the order of the number of nodes in the tree, order of n.
Mm-hmm.
The space complexity is not order of n. We are making use of the queue, but yeah, where for a skewed tree, it can be order of n, still order of n.
Okay. So is this right, Vijay?
Yeah, correct. Actually, yeah, order of n,
And CG?
space and
You
time
got this?
complexity.
Okay, got it.
Okay. So basically, I think I'll just draw this tree again. Let's say, okay, 10 to. Should I draw the whole queue that is happening, or you got it?
If you can draw that, that will be helpful.
Okay.
Just to know how that queue gets populated, and then
Okay. So
maybe you can draw a small tree as well as the
yes.
queue.
Fine. This is a tree. Okay. So the answer has to be 1 plus 2 plus 3, which is 6, 10, 15. Fine. So basically, initially, right, let's say your sum is 0. Initially, your queue will have only one inside it. Okay. And we are processing this till there are elements into the queue. Till there is even if there's a node, we keep processing the queue. Okay. And we remove from the front, we add it over here. Okay. So first, what do? We so till the queue is not empty, we are popping whatever element is at the start. Okay, that is what a queue is. Okay, so first we do sum plus equal to 1. Fine. So now your sum is 1, and what we do is inside the queue, now you'll have two elements, which is you add 2 and you add 3. Is that clear? And your sum is 1 so
5.
far.
Yeah. 1. Yeah.
Sum is 1 because this is your queue and you have added only 1 till now. I mean, you have popped only 1 till now. So after popping, your queue is empty, right? Okay, wait. So see this, while queue, first you pop the root. Okay, this is your 1.
1. Yeah.
Okay, now your sum is 1. Your queue is empty now.
Yeah.
Because you have popped it out.
Mhm.
Okay, now you're checking if there's a node dot left. The node, so if this is your tree, now since there is 2, now what will happen? So here also sum is 1, but your queue is now 2. Okay.
Mhm.
Similarly here at this step, your sum is still 1. Your queue is 2
2
and
and
3. Fine.
Yeah.
Now this loop is over. Now it will go back up.
Mhm.
Again, what will it pop up? What will it pop? It will pop 2 from the front.
Okay.
Okay. Now sum is 1 plus 2, 3. And there's only one element in the queue, which is 3.
Yeah.
Fine. So similarly, so now your node is 2, right? If there's no 2 doesn't have any left, nothing will happen. It doesn't have right, nothing will happen. It will again go to queue because there's at least one element. So it will go to 3. Right? So this will become 6. And now queue is empty. Nothing happens here, nothing happens here. Out, return result.sum. Okay. So here it starts with 1. And your queue, did you understand? So basically now your queue is 2 and 3 and your sum is 1. Now
Yeah.
it'll remove 2 from the queue. It will add
The
Okay,
children
tell
of
me now. Huh?
yeah, see, it should add the children of Q, but there is no children. It will
So your Q is still 3 and your
yeah.
sum is what? 1 plus 2, 3, right?
Yeah.
Okay. Now it will again go here. It will remove 3. It will add. It will add to the sum. So wait. So sum becomes 6 and it appends Q. So what is your Q now?
4 and 5.
Only 4. It has appended only this one,
Yeah,
right?
yeah, okay, yeah, it's only 4.
Right. So next time it will remove 4, append it to this. Sum equal to 10 and Q will
5.
become what? So 4 doesn't have a left. So this doesn't add. So it will add 5.
5.
Right. So
Yeah.
since there's one more element, now it will remove this. Sum will become 15 and your Q is empty and eventually this will return.
Okay.
Fine.
Yeah.
1 plus 2 plus 3 plus 4 plus 15. Okay. So okay. So this is done. So basically, my original question was, okay, return me all these sums. Okay, Sue, so this is the next question for you. Okay.
Yeah.
Return me the height of the tree. Height of the tree. You understand height of the tree?
The edges that we
And so
discussed.
basically number of the edges from the root till your deepest leaf.
Mm-hmm.
So if there are, let's say 1, 2, 3, so return me 3 over here because there are 3 edges.
Yeah, yeah.
Okay. So do this BFS way.
Or do this BFS way.
Yes.
Okay. DFS I know.
No. So that is what this topic is about. We did DFS yesterday.
Okay.
Right. So here today we are doing BFS Qs.
Okay. Yeah. So I will basically have create a class. I mean, in Java, like along.
Don't
with,
worry. Don't explain me the code right now. Explain me how will you calculate the height using Qs.
So
So
if
okay.
I
So
have to using the queues, so what I'll do is so initially if it is BFS way, I'll start with the root and I'll also put in an element in the queue that holds the node as well as the height. Or if node for some way, if we can node define a node in a way such that it can
okay.
hold
So
the
you're
height.
saying this is 10, 0.
Yeah. So I'll
Okay.
push 10, 0. And then when I push like when I'm pushing left and right to the queue in the same old code, I will push like 1 to the queue. Like I'll increment that whatever I pop out the value, add 1 to it and then push the next elements to the queue.
Okay.
So here when you have like, is it the tree that I should assume, Ankur, on the right side?
Yeah.
Yeah, so initially I'll push q root comma 0 and yeah, while q is not empty, get the current element from the queue, which is root comma 0.
Okay.
Yeah.
So let's say height of
yeah.
the tree is 0. Let's say initially. Okay. Now.
Yeah. So now if root dot left, like no node dot left is not null.
Okay. So let's say if left.
Yeah. If left, then push like this left and height plus 1.
Okay.
If
And
right,
similarly for if right. Okay. Then.
yeah, same height plus 1.
Okay.
So your height
what do you return?
height. Your height variable at the end.
So you're saying you're changing this height itself here. Is that what you're
You
saying?
can do here small thing you can do actually.
Uh-huh.
You do while loop, right? After while, you can do size of the queue. Okay. Again, you can start the while loop. In that while loop, you will process all the elements or nodes. Then what happened once you come out, you increment that number, like that is a height 1, height 2, height 3. What that means is each level is going to be 1
Yeah, Vijay, I
original
got that.
condition.
I got what I was trying to say. That is my next. I'll go to
Okay,
that
go ahead.
pattern
Go
using a
ahead.
different question.
No, here in the height variable, whatever you have defined, right, you are updating it with height is equal to q dot pop, and your height
Okay, so
will
your
have
return
the
height.
final height. Yeah, written height. That's all.
So you're saying if even if there is 3, there is 4, and there is 5.
Yeah.
Initially this is 0, this is 1, this is 2, this is 3, this is 4. Initially your height equal to 0, and as you're going down, you're updating the height and you're returning. Yeah,
Yeah.
that's fine. Yeah. So Shiji, is that clear?
Yeah.
So basically this is also a pattern. So basically here what Sue said, instead of just storing root, so basically in this question we were storing only root, right? We were storing only root. See this pattern, q dot pop. If node dot left, you append. If node dot right, you append. Okay. So similar, same thing here. So she did root and 0. So at every depth, right, at every node, she is calculating what is the height from the root till here. So this node, right, this is actually a parent. This is a parent. So when you go to a queue, whenever you extract some node, right, it's a parent node, and this height is the node of this parent of this parent. So when you do left, right, when you go to the left, let's say there is 3 here. So the height of this node will be whatever height this was plus 1. So she is putting it back into the queue. Am I making sense? So basically, let's say this is your tree. So silence means you didn't understand. Okay, so what I'm assuming. Okay, so what is the height for 6? Sorry, yeah. So what is the what do I say? Wait.
3. Height is 3.
No. So actually, the height of 6 is 0. Height of 1 is 3. So what Sue actually mentioned was she's actually calculating the depth of 6. The depth is 3. Height is 0 of 6.
We are calculating the height of
Yes.
the end of 3, right?
Height of the root.
Okay, so
And depth of height of the tree, height of this root is 3. Depth is 0. Right? Similarly, this one depth is 1. Depth is 2. Depth is 3.
For the
Fine?
depth, we call it levels, right?
Yes. So basically what she is doing is she is actually calculating the depth of the tree.
Yeah.
Okay, so it's nothing. So height and depth, that's the same. Is it clear, Siji?
okay, height will be the same as the same level will be calling the height.
So basically when I said calculate the height is basically this thing. Okay. Right. So what Sue mentioned is that she starts from root. Oh, wait, what happened? She starts from root. And she is trying to find out the depth of the tree.
Okay.
Right. So she starts from here, she keeps going down. So she is actually calculating the depth. So by calculating the depth, you get the height. Right. So now what she is doing? Okay. Now what is the depth of 6? Depth of 6 is depth of 5 plus 1. What, right? So 2 plus 1, 3. What is the depth of 5? Depth of 3 plus 1. 1 here. What is 3? 1 is 0. So 1 plus 1. So this is 0, right? So this is 1. Right? So what the idea is, whenever you see a node, the depth of that node is the parent's height plus 1. Right? No? So initially what she added in the queue is the root and the 0, which is like the grandest father. Okay. Now in this she's extracting one node. It extracts the height of that node. Initially this is 0. This is root. Right? Now if there's a left, what she's appending is she's appending the node and also the depth of the tree. That depth of that node, which is depth of the parent plus 1. Similarly for right, q dot append right height plus 1 or depth, and eventually she returns height. Is this clear? Easy.
Okay, so from the root, it will be 1 and it will append 1 and 0, and then it will come to.
Yes. So basically, this is the node, and this is the sometimes so she's adding into the queue. So basically, this is a set. This,
Yeah,
this
so
is an object. So okay, I think
so
that.
if you, I want, it will be helpful if you just go through the diagram, that tree, and then just see.
Okay. So this is this was a tree, right? One.
Mm.
I'll draw it again. Okay, I'll put it simple. 1, 2, 3, 4, 5, and 6.
Mhm.
Okay.
Yeah.
We are calculating the depth of this one. Let's say this is 2 and this is 3. Okay, we are calculating depth with 1, 2, 3, 4.
Mhm.
Okay. So initially, in the first implementation, what we were doing is we were appending only 1. Then
Mhm.
we were appending only 2 because we were calculating only the sum of all the nodes.
Yeah.
Right. What Sue is appending here is along with the so this is Python. Okay, this is Python implementation.
Mhm.
Java you'll have different. So that is why she said she'll create an object or a class.
Mhm.
I mean, she'll create an object and she'll put into that object she'll put two things. One is the node value and one is the height or the
Okay.
depth. Sorry. So
Mhm.
initially this is in Python. This is a set. So when you
Okay, so
extract, yeah.
in
Go
the
ahead.
first node, when we reach node 1, we'll be adding 1 and the height of that node, that is 0, into the queue.
Yeah, no, don't call it height. Let's call it depth.
Okay, depth into the
Okay.
queue.
And so basically, when you do q.pop, right,
Mhm.
it returns 1 and it returns 0, which and if you did, let's say you did node and height, or let's say this is depth equal to q.pop. Okay, or let's say this is 0. Q.pop node will be 1, height depth will be 0.
Mhm. Okay.
Okay, so now what will happen is next.
No, this is if it is Python, it will be no, it is just a list of 1 and 0. Node will be assigned 1 and the depth will be assigned 0, right?
No, this is a list. This is a list of sets.
Okay, in the queue we have a list 1 and 0, and we are popping the first.
No. Queue inside the no. See, okay. Do you know the difference between list and a set in Python?
I know list. Set means that it will be just.
No, sorry, this is not a set. Sorry, tuple.
Yeah.
Do you know what
Tuple
tuple?
one is immutable and the other is mutable.
Yeah. So what can a list have? List can have anything, right?
Anything.
It can have numbers. It can have floats. It can also have objects. It can also have dictionaries.
Mhm.
So let's say you have this. So let's say you created some list, and let's say if you did, you can create list 0 equal to, you can create a dictionary of 1, 1.
Mhm.
Similarly, list of 1 equal to, you can create one more dictionary 2, 2. So these two are different, and list of 2, you can just add 2. So now your list has 3 elements. First is a dictionary. Next is also a dictionary, and you have 3.
Okay.
Is that clear?
Yeah.
So basically, this is a dictionary, okay? And set is nothing but set is the same. Set is also basically you can have a list of lists. So let's say this is your list, and you can have a list in this. Let's say 1, 1, 2, 2, 3, 3. Is that possible?
Yes.
Yeah. So that is what. So all I did is, instead of calling this list, I called it as tuple. So
Mhm.
in this queue, right, you're adding 1 and 0 in one list.
Mhm.
So so this is the first element. The first element is 1 and 0. And if you do pop, you'll get this whole list together back.
1 and 0. Yeah, got it.
Basically, you're clubbing them together.
Mhm.
Or you can also create an object and put object dot dot value equal to 1, object dot, so let's say you create an object, obj, okay, let's say you call it node. You can make object dot val equal to 1, object dot depth equal to 0, and inside your queue you can store object dot append only object. So when you extract, you get back this object. When you get back this object, you can extract the node, sorry, not this, but the root, the root, and you can also get the depth.
Okay, I
That's
now
the
understand.
idea. Huh?
Yeah.
Okay. So
Mhm.
is this clear what we did? So initially
Yeah.
we had 1 0, right? So now we extracted 1 and 0. Okay, this is the tree, right? This is 1 0. Now this will get extracted. It will go to here. What this will add? This will add back into the queue 2 and 1.
Mhm.
And also add in 2, 1, which is these two nodes.
Okay.
Right? Now now this is your tree. This is your queue. Okay?
Mhm.
And so this is the node and this is the depth. Now 2, 1 has to be extracted. Now when this is extracted, it will add what? It will add, so this will become 2, 1. This will become 3, 2. Clear?
Yeah.
So 1, you go to 2, you add this, and then you extract this, you append 3.
Mhm.
Right? Now this 2 will be extracted now. Now this 2 will be extracted. It will become 3, 2, and then here what was it? It will again add 3, 2. Right?
Yeah.
Now this will get extracted. This doesn't have anything.
Mhm.
Right? Now then your 3, 2 will be extracted. This will add 4, 3, and that's it. Then this will get extracted. This will add 5, 4.
Mhm.
Then this will get extracted. Now your depth variable is 4. It will return 4.
Okay, got it. Thanks.
So basically 6, whatever it is. Yeah. Clear?
Yeah, that's clear.
Okay. And okay. Now, Sue, so here's the question, one more for you.
Uh-huh.
Okay. So since you're given a tree and return sum of each level. Okay.
Yeah.
So basically, if this is your tree, let's say 1, 2, 3, 4, 5, 8. You return an array of 1, 5, 8, 13, and 4, which is 17.
Yeah.
Clear?
Sure. Yeah, it's clear.
Okay, I think you know the answer, but I think you have you done this before?
So I know the level order traversal, like using the queue, again, BFS approach.
Okay, Shiji, you
Same.
want to try this? I don't think, if you have not, do you remember how to do this, Shiji?
Ankur, I want to step out for a while. I'll be back soon.
Okay, fine. No, I've recorded. Yeah, no worries.
Thank you.
Yeah, Shu, then you go ahead.
Yeah, so like level order traversal, like I know the concepts, all of these, Ankur. So I think I'll just apply the same concept. So we'll initialize a list in Java, if it is Java, and then you start with queue, queue dot add root.
Okay. Okay.
And while the while loop starts,
So basically, before that, do you want to explain to me what your approach is? I don't want you to code it. Basically,
yeah,
I'm your
so
interviewer.
my
They explain
approach
to me.
is, yeah. So my approach will be, I'll have two queues. One is the running queue, and the other is the queue to which I add, or even I'll
No,
not
you're not.
even-
You're not telling me the approach. You're telling me the approach of your code. I want you to tell me the approach of your general idea. How you're
Okay, the
calculating the sum.
general idea is I will do a level order traversal. So initially, I will process one in the tree. Okay, so that's initially I'll add one, and then I'll process that level. So when I am done processing that level, by then I will add all the next level elements to the queue, which is 3 and 2.
Okay.
And then I will, so at the start of each, like at the start of the while loop, I will basically read what is the size of my queue, which will tell me how many nodes I know I should process in that level. So initially, when I added the root, I will just have one. So I will only process one node and I'll call it end of the level. But
Okay. So let's say you just okay. Let's write the code then.
okay.
Okay, I understood. Okay. I think this is a very simple example. Like if you've done it, so there's no point in explaining.
Yeah.
So give me the code. So you
Okay.
want while queue first?
Yeah, while not of queue is empty. So initially you added queue
Root.
dot root. Yeah, while queue is not empty, just read the size of the queue.
Okay, and then
And then run a for loop for that size.
so basically first what do you do? Find out the length of the queue,
Yeah, find the length of the queue.
which is nothing but the size of the previous level. What do you
Yes,
think?
exactly. Right.
Okay. Okay, and then okay. Let's say you calculate length and you do a while loop.
Yeah, so I have a while loop. No, I will not calculate length. So inside the while loop, while not of queue is empty, if you type it in, I can go line by line.
Again.
Yeah. If you're not typing,
No, tell me. Okay, so while queue, then what? Sorry, I
while
didn't.
queue is not empty, that is
Uh-huh.
my loop, right? And inside that loop, the first step is what is the size of my queue at that point,
Okay,
which
so
is the
length
number
is
of nodes in that level. Yeah,
okay.
the size, it's not length, but yeah,
Yeah.
length.
So size. So basically, this
Yeah,
is
the
Python.
length
Okay.
of the queue. Now I'll run a loop for int I equals to 1, I less than or equal to length, I plus plus. I will process so many nodes in of that level.
Okay.
So in that I will, so here I'll also initialize a variable called sum, like level sum,
Okay.
equals
Level
to 0,
sum.
and yeah, level sum. And then now write a loop for int I equals to 1, I less than or equal to length.
Okay. Sum plus equal to
For node in queue,
not that well, right?
yeah, right. Yeah. So you will only process this for loop will only run for that length that we have already seen at the beginning of this queue. So I will only
Okay.
process the nodes of that level.
Oh,
It's not
okay.
for
So
node
basically, okay.
because
Okay.
I will be adding more nodes. Like I'm getting like sum is equal to node dot well, and then immediately for each node, if like left is not equals to null, right is not equals to null, I'm adding to the queue. So my queue size is basically building up, but I will process them only in my next level.
Okay. Wait. 1 second. So let's say you added. Okay. So let's say you only added. Let's say whatever. If there are 5 elements in the queue, you add five nodes,
Yeah,
right?
at the for loop will run for 5, like from 1 to 5.
Yeah. So if there are 5, this will run for 5 times. So
Yeah.
queue dot append node dot left.
Yeah, and then if
So
node
let's
dot
say
right not equals to null, then q dot add node dot right.
sorry. So if node dot this one,
Right?
right?
Then, yeah.
Similarly,
Q
you
dot,
append node dot right.
yeah. And then at the end of this for loop, to your list, add your sum.
Okay. So result
At
sum
the
plus
no,
equal
not at
to.
the end of for loop. Outside the
Oh,
for
okay. Yeah.
outside the for loop, you will see result dot add sum. So
Plus equal to sum. Okay. Now what? Now okay. Huh?
no, not this. So you are already doing the level of that sum inside this for loop. So outside this for loop, you initialize the sum to 0, and inside this for loop, you are calculating the total of that sum. And outside, once you exit the for loop, you have the total of that level. Just add this sum to the result.
Yeah. That's what I did. So okay. Okay. So basically dot append.
Yeah, result at append. Yeah. I mean, I don't know the
Yeah. I got it.
but I'll
So this
just
is the
result
level sum you added to the result. Okay. Fine. Now
yeah,
what?
and then return result.
Wait. What did you do? Wait. I'm not. I'm confused. Let's
Okay.
say okay. Let's say you started with 1. The queue is only one. It has
Where
two
I
and it has
pointed.
three. Huh?
So I'll explain.
Huh.
So I have this, right? So I'll initially, where will I start? Like, add some more children, Ankur, so it will be easy. Under 2, under 3, like any number of children. So
Okay.
like for 3, don't add 9, 10, but just add 9. Under 10, add one more level. Yeah. So like this. Okay. So
Hmm.
now I started my queue with adding the root 1, right? Which is my
Mhm.
level 1.
Hmm.
So I read my size of the queue. It is just 1. So
Hmm.
so I total my sum to be 1. So I'm inside my for loop now, where I'm iterating through the size that I read. So I will
Mhm.
only pop one element, which is 1,
Hmm.
and I added my sum, which is 1, and
Mhm.
then I added my children 2 and 3 to the queue.
Okay. So now your children is 2 and 3.
Yeah. Now
Wait. Okay. Wait. Okay. So what you're saying is you're emptying the queue. Okay. So you're saying you're emptying the queue for this length.
for that level, for that size, length.
Oh,
For the-
okay. So you get one, you remove it from the queue for like one size, like for if for length 1,
Right.
you remove 1 and you add 2 and 3.
Right.
And then you process 2 and 3, you get 5, you append, so this becomes 1 and 5. And at the same time, this is the answer, but you also appended 5, 8, and 10, and these two
Right.
are removed.
Right. Those will be removed. Right.
Okay, and then when you did 5, 8, and 10, you got the length, which is 3. You don't add anything here. You don't add anything here. So you add only 9, and but you append 1. So this becomes 1, 5, 3.
Right.
I mean
My,
your result. Sorry, not 1, 5, 3.
not 1, 5, 3.
1,
It is
5,
1, 5,
23.
23.
Yes. And your queue has only 9, this element right now.
Yeah.
And you go to the next, you don't append anything, you append 9 over here. Wait.
Get pop 9 from there. Like right now, my queue size is only 1. I'll just pop one element,
And
and I
this
see that.
goes. Oh, nice. So Shiji, are you back? Listening? She's not back. Okay. Yeah, this is good. Nice. Yeah, this will work. Yeah, this is a new technique that I learned actually.
Oh, you don't know this one?
I know, but I used to do a different way.
See, this is equivalent to BFS, right? Same thing, whatever she has done, right? You can find the height, you can append into like a reverse order, everything you can do this one.
So
what
basically,
exactly you do, right? You use the queue, right? Queue, how you want to add, right? You want to add at the beginning or you want to add at the end, right? Now in this case, what you do, you will add at the beginning. Once you add the beginning, and then you remove from the end. Basically, you use the DQ. DQ means you can able to retrieve from the both ends. You can able to take the elements. What happens is how many elements are pending is nothing but that level. That's the meaning of that. Assuming that, right, you want to find out the left tree, right tree, everything is same way. You can find this approach. I had Amazon one
so
of the
this way only, right? So whatever she said,
Mhm.
same way, right? You give you sort of a different approach.
Similar, you don't have to use a for loop. You can just use a while loop. Just go with the size whatever is there. That is also easy.
Yeah.
For is also is fine. You can just make like a size equal to whatever, and then size is greater than whatever. You can just greater than or equal to 0, and then you are done. If it is greater than 0, then only you will go inside.
Okay, so that means there are 2 questions which are done, which is how to DFS and binary trees in queues. Calculate height is done. Given return back an array of sum of each level. So this also solved. Okay, now I have 2 more questions now, but Shiji is not here yet. Shiji? Okay, she'll watch
Yeah,
the
I
video.
don't think so. She's there.
Watch
She's
the video.
gone.
So okay, and basically what I used to do was like this is what I used to do is basically what I do is after, so basically she is calculating only the length, right? She's popping from the queue. I don't actually pop from the queue. but
Mhm.
I create a, so let's say this, right, a while queue.
Mhm.
I go through the elements of whatever is there in the queue. I append all the elements into my new list called let's say temporary queue.
Mhm.
Right, I append into this,
Mhm.
and then I change this to list.
Mhm.
So this way at every level, right, I'm not doing any pop. I'm just
Mm.
changing my
Position.
level at each point. So
Makes
first I
sense.
process this, then I process this, then I
Mm.
process this, but I'm not changing the queue. I'm just creating new. I think Sue's or her approach is better, because what I was doing is, it was creating many arrays and not
Correct.
deleting
You
them.
shouldn't be
but
doing that.
using
Yeah.
them. Huh?
You have to use the BFS, right? BFS is the level order is the
No,
BFS.
I also use BFS only. But
Mhm.
what I used to do was, okay, so let's say I have my while queue. Okay, now let's say I have a temp list. Okay, now what I do is, for node in queue, right? If node dot left,
Mhm.
I'll append temp dot append. I'm not appending the queue, I'm appending to my temporary list. Append node dot left. So this is my next level. If node dot right, if node dot right, I again do a temp dot append,
Oh, now I got it. Okay.
right? Node dot right, and here what I'll do is, I'll assign queue equal to temp.
Mhm.
So this way, next time it will come here, right? It will be this array.
Basically, you are adding into directly that whatever the level, right? Value. Makes sense.
Yeah,
Here we
but
are
no,
calculating.
but the thing
Yeah.
is, when I'm reassigning this, right? When I'm reassigning this list back to queue, whatever elements were over here, they are still in the memory, right? But what? So my
This also similar approach.
similar, but I think when you're popping,
The only difference, right?
they will still
What
be there
you
in the queue.
mentioned, right?
Huh?
Your list, and here is we are using a array of list of results. That's the only difference. You're directly what you call adding the number to your list. Both are same.
Yeah. So basically, I think Sue, you got it. But okay. So I'll give you another question now.
Yep.
Okay, Sue.
Yeah.
There are two more questions.
Yeah, Ankur, I'm back. I just want for the in the last one, you just wrote temp with a square bracket, just a semicolon, right? What does that mean?
This actually makes so this actually creates a new. Let's say this is my one. Let's say this is my 1, 2, 3, right? And let's say I am doing, so this is present in my let's say in my memory. What this will do is, so let's say my temp pointer is pointing to this list. Okay.
Okay.
Now by doing this, what will do this? This will create a new array, and Q will point to this. So there'll be now two arrays, 1, 2, 3, and 1, 2, 3. But if I do Q equal to temp, actually I can do this also. Basically, what this will do is, this will point both to the same pointer. Yeah, so that is all. There's a difference between this. This is what point dot is doing. So I think here dot is not actually required. We'll just change the pointer to this one new that we made. This is actually not required. Here, CG?
Yeah. Okay.
Right. So basically what I was doing is, at every level, right? So let's say I'm at 1, and this is 2, and this is 3. After I'm done with this, my queue will have only 2 and 3. And when I'm processing this, after I've done the processing, I'll have in my queue the other nodes of this level. Basically, same thing even Sue was mentioning, but her approach was a bit different. But that actually made also, that was also like very easy to understand actually. You want to see that?
No, I don't. You can go ahead. I can look at the recording later. It's fine.
Okay. So now there's a different question. Now we are moving away from queues now. Queues is done. So that is how you do BFS. You start from the root. You look at you process the next level before you go to the next level, right? So basically DFS, it goes as deep as possible, then returns back. So that is DFS. Or I mean that is DFS. Depth first search. Breadth first search is you start from your root, you check the next level, then you check the next level, and then you keep going down. Right? So by using this approach, eventually you'll land up at all your leaves. Or there's also one question: return all the leaves to me. Like there's a leaves means return all the leaves in the array. Right? So you can do using BFS. You process the first, you process the second, and as soon as you go to the next level, you return that one. Right? So that's the difference between BFS and DFS. Okay?
Okay.
Okay. Now let me look for the question. Can you see the screen? What screen do you see?
See an empty screen.
Okay.
Okay, I just scroll.
We can see.
Okay, 1 second. Okay, the question is, which one should I give first? Wait, okay, let's say, diagonal transversal of a binary tree. Okay, now let's say this is my tree. 8. So this is the question for you. Okay, I want
Okay.
you to solve it. And I hope, have you seen this question before?
I'll understand the question, then I can.
Okay, 3, 6, 7. So this is 30. So this is 1. This is 4. Okay. Now the result. This is my result. We returned 8, 10, 14. So basically, wait 1 second. So basically, this is what you return. Your level 0 is 8, 10, 14. Your level 1 is 3, 6, 7, 13. 2 is 1 and 4. So basically, this is one diagonal. This is one diagonal. And this is one diagonal. You understand?
I didn't understand the 7 and 13 part. So they
So
will be
3, 6, 7, and 13, they are on the same level.
okay. Yeah, I didn't see this question. Yeah, I think I understood the question.
Right? So basically, in BFS, you first see 8, then you see 3 and 10, then you see 1, 6, 14. But here, there's a different this traversal is different, diagonal traversal. So first is this 10, 8, 10, 14, then 3, 6, 7, 13, then 1, 4. And this 13 is the left node of 14. Okay?
Got it.
Are you seeing?
Yeah, I'm seeing your screen, Ankur.
Okay.
Yeah, we are able to see.
Yeah. So any ideas? Vijay, have you seen this question before?
Diagonal, I don't think so.
Okay.
I didn't remember I did.
So yeah, so
diagonal.
solve it. So solve it with others. So this is not BFS, this is not DFS, but this is something called something that you have to observe. You can call it property based. Some property. You have to figure out what the property is. Basically, you don't have any idea, right? So what's 8, 10, 14? Why is 3, 6, 7, 13 in level 1? Why is 1, 4 on the level 2? So you have to figure that out, and then you have to solve it. So that is that question. So you have to understand why is this ordering like this?
1 second. Yeah, so if we take like I did a diagonal traversal something on a matrix sometime back.
Mhm.
Say if we can assign each of these nodes values like the level and the position. It's like in
Mhm.
this tree, 8 has level 1, position 1. Okay, so let's put 1 comma 1 there. And the next level 3 will have level 2, position 1, 2 comma 1. Then we'll have 2 comma 2, level 2, position 2. And then the next level you have 3 comma 1 for 1, 3 comma 2 for 6, and 14 will have 3 comma 3.
Okay. Okay. So
And
2 is a level, and what is 1 and 2? 1,
the
2, 3.
position
Okay.
and that level
From its
in,
left hand mode side.
yeah, from the left side, what is the position like 1,
Okay.
2, 3.
So similarly, this
So
is 4, 1. This is
yeah,
4, 2, and this is 4, 3.
right.
Okay.
So if you see, if we start with 1 comma 1, 1 comma 1, 2 comma 2, 3 comma 3 are like from there, if you increase like the level as well as the position, they will be in the diagonal. So you started with 1 comma 1.
Hmm.
So you will have 1 comma 1, 2 comma 2, 3 comma 3 added.
Okay.
Similarly, to move to go to the next level, you will basically increment only the level. Then you will land up at 2 comma 1.
Uh-huh.
So then you will increment the level as well as the position for them to be in diagonal. So it will be 3 comma 2.
Wait. Is my 4, 4 and 7 is 4, 2, 13 is 4 comma 3. Okay. You said 2 comma 1, this is 3 comma 2. And then you have 6, 7, which is 4 comma 2. And you also have 4 comma 3. Okay.
So 4 comma 2 and 4 comma 3, will they be in the same
Yes,
diagonal?
they have to be in the same.
Okay, so this is like only 2 comma 1, 3 comma 2, 4 comma 3 are coming in, but 4 comma 2.
Hmm. Fine. Yeah. So this property didn't work.
Yeah, did not work,
Yeah.
right?
So try something else. Shiji, Vijay.
I'm thinking a little differently. Something this angle I did.
No, don't think about where you did before. Solve
Mhm.
it right now. And
Let's
Shiji, you
see.
also. Like, what are you
Yeah.
seeing? On what property is my diagonal thing working? Why is this one diagonal? Why is this diagonal? Why is this one diagonal?
I'm just thinking.
So I'll draw this. I'll draw this tree again. 8,
1 come
10,
0 come
14,
0.
13, 3, 6, 7, 1, 4. 10. This is one level. Another level is 3, 6. 3, 6, 7, and 13. Next is 1 and 4. So basically, since these are level 0, right?
I got it actually.
Okay.
What we have to do is we need to make a whatever Sue was mentioning, right?
Hmm.
Parent. Based on the parent, you need to identify each level. What is the height, right? Based on that, we have to build it. What I mean to say is, for example, if you are in the 8, right? 8 is the parent, right?
Hmm.
Now I am passing a parent and then my whatever the position or
What is this? Yeah, tell me.
height.
So what is this? 0.
First is 0, you pass it. Okay. Then you will call the left.
Okay, wait. Okay, this is 0. This is 0. Okay.
Uh-huh. And then you will call the 3, right? 3 height will be height or whatever the level will be 1.
Okay, 1.
And then 10 level will be same thing, like it will be 1.
Hmm.
Like that you calculate each level, right?
Hmm.
Now you are building the stuff complete.
Okay, this is 2. This is 2. This is 2.
Exactly.
Okay. Now what?
Now, once you build everything, now for a diagonal level of how is the diagonal is going to be numbering? Any idea?
That is what the question is. How is it?
Diagonal.
You need to figure that out. Sue, Fiji, any idea? So why is 8, 10, 14 on the same level? So let's say this is 0, this is 0, this is 0. Okay. Okay.
Oh, so you will give the positions from right to left, not from left to right.
Say again,
So
say again.
in a level, you will
In a level. Okay.
in a level you give, no, even that does not work. Sorry, my bad, uncle. Yeah, no idea.
Huh?
It
Yeah,
is not.
no, I was initially thinking if you can give the numbers from right to left instead of left to right, it can work. But then in this inner, like the last level, you will be giving.
So Shiji, you're not saying anything. Did you see anything? Did you see a pattern?
I was just thinking when we add it to the queue, the last one will be popping. We can pop out, but this 13 doesn't make sense there.
Yeah, it's a tricky question, but I just want to see. I mean, sometimes you want. I mean, it's. I mean, when I looked at this question, even I couldn't figure out what the pattern is. I actually looked at the solution. Then okay, this is the pattern. Okay, so that is something. So I wanted to see if you guys can come up with the pattern. But I couldn't come up with it when I saw this.
Can you give more hints, uncle, so we can try?
I don't know what else hints to give. So basically, let's say you're 8, 10, and so yeah. So I'll give you a hint. I won't give you the solution. Okay. So 8, 10, and 14 are 0. Okay. Okay. So if you see, okay.
So in a level, basically they are.
No,
coming
forget level. Forget level.
Oh,
Forget
don't
level.
have to go. Okay, got
There's
it.
no level here.
Okay.
There's
got
no
it.
level here. Okay.
I see.
You start from the you start from 8. Okay. 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 What is 10 relative to 8?
Right child.
What is the level of 10?
1, 2.
0. Not level in the sense here in the answer.
0.
Right?
No,
I've
what
given
is
give.
zero?
Huh?
No, what is the question? I did not.
No. In the final answer, 8, 10, and 14 are at level 0. 3, 6, 7, and 13 are at level 1. In the answer, 1 and 4 are at level 2, according to the traversal.
Okay.
Fine. Okay. What is 8? 0. 10 is also 0. And what is the relation between 8 and 10?
How do we know 10 is 0?
I'm giving you the answer. It is 0. I'm showing you the pattern.
Yeah. You told me, but how do we know when we go to the right that it is 0?
The uncle didn't tell that yet. He's just saying the answer has 3 levels. So this is in the first level. We have 8, 10, 14.
So I'm trying to help you figure out what the pattern is.
Okay.
So the interview said this is the answer.
Okay.
Okay, this is the final answer that I want.
Okay.
Okay. So he says that 8, 10, and 14 are in one at the level 0 or in the first in one diagonal.
Okay.
Right? In the other diagonal you have 3, 6, 7, and 13. Right? And you have then 1 and 4. Okay. Now you are trying to figure out, okay, what is the pattern? You see 8 and 10. Then you see 14. You see 3 and 6. You see 7. Is there anything you're seeing? So what is 8 or 10? They are parent and child?
Yes.
Right? So the levels are same. So they are getting same. You're seeing they are same, right? 10 and 14. You're also seeing they are same. 3 and 6. They are same?
Yeah.
6 and 7. They are same.
But how about 13?
Yeah. So that is a different thing that you have to now understand. Why is 13 1 and not same as 14. Okay.
So we
So,
have to,
okay,
so
so-
if 10 has another child on the left, that will be also 1.
Yes.
Okay.
Yes. Okay.
So then
Now,
we-
okay. I think you got it. No, you didn't.
Yeah, so apart from the right children, we also have to take the left child of the like sibling right child.
Second. Okay.
So for 3, the sibling right child is 10. So for 3,
Okay, wait. You see, this is 0, this is 0, 8 and 10, 0, 10 and 14, 0, 3 and 6, same, 6 and 7, same. Right? Okay. Now, 12 and 10. What is happening? 0, 1. What is 14 and 13? 0, 1. What is here? 6 and this 6 and 4. This one. 1 and 2. What is here? 1 and 2. What is here? 0 and 1. Following?
no.
No?
No.
Can you scroll up? You're seeing half of your screen, not full. Yeah.
Yeah, now it's
Okay. 8 and 10 is 0. 10 and 14 is 0. This one?
Yeah.
Okay. That is one thing. Now, okay. 3 and 6 is same.
Mhm.
6 and 7 are same.
Yeah.
Right? Okay. These are the only right nodes. Right? Okay.
Mhm.
What about the left nodes? 14 and 13. 0 and 1. 10 and 12. 0 and 1.
I got the idea.
Okay.
Ankur.
No, okay. Oh, wait. 10 and 3. 0 and 1. What about this one? 3 and 2. 3 and this one. 3 and 1. They are also different. So left is 1 greater than the parent. What about this 4 and this 6? 6 is 1, 4 is 2. So so if you see the right pointer, right child.
You will increment 1.
No,
for the
right child, it is same as parent.
right child is same. Yeah.
Right? And left child is parent plus 1.
Right.
Right? So this is what the pattern is. I know it's something that is difficult to understand, but that is what
So
the
it
question says.
doesn't matter in which order we return these values, Ankur, like 8, 0, 14 and like 3, 6, 7, 13 or 3, 6,
I think if you do BFS, if you do 8, I think it doesn't matter. I mean, the order doesn't matter.
Okay.
You can do this way, Ankur. This one, how we have to solve here is same approach. The only difference here is, right, when you have a
Yes, exactly.
yeah,
I
I'll
got
tell
it.
you.
You don't have to say anything. I got it.
Yeah.
I mean, so basically you're saying you start from a queue.
Q,
and
then
you
what
start from
happens?
root 0.
Correct.
And then if it is left, you append left and you do 0 plus 1. But if it is right, you do 0 only. Like whatever
No.
was the
I
root.
was thinking little differently. What I was thinking was more like a BFS route, assuming that, right, each element, right, each row or each level, the last element will go to the first. The second, like that reverse direction, you have to keep reading the elements. That's where you can build the entire list.
No.
What?
Wait, say again.
See how it works, right? Now you have 8, right? First row position is what? Last element. 10. What is the last element in the second level? Okay. Next to go 14. Last level. Last element. Are you following?
So, okay.
Now all 8, 10, 14 will be the last element in the each level, right? Next will come to second level, second element in the each level, 2. I mean, like if his size is whatever, right? Unknown, right? Each level like that, you need to build this one in the reverse direction. Then you will get the results, entire results.
No, why? But then why? How will 7 and 13 will fall into same level? How will
Which one?
7, 13 fall in the same level?
7.
And 13. No. So how will 4 and 1 fall in the same level?
Okay.
4 is down, 1 is up, no?
4 is
4 is at
down.
4 is at level 3, and 1 is at level 2. I mean, if you go from up.
Other than leaves, I think this will work actually. If it
No.
goes to the leaves, last element.
No. But even if 4 had 2 and 3 over here, 1 and 4 will still be in the same same answer, same level. This is the only property. If you go right child will have the same whatever parent had, and if you go left, it will have parent plus 1. So if parent is 0, right will have 0, right will have 0, but anything left of this parent will 1, this will be 1, this will be 1. Similarly, if this will be 1, but this will be 2. This will be 1, this will be 2, 1, 2. Now 2 right will be 2, this will be 3. This will be 2, this will be 3, 2, 3. Similarly, 3, you go to 3, this will be 4. So when you're connecting, right, so this is all your answer. Similarly, this is your answer. Similarly, you collect all these 3s, you collect all the 4s. Yes. And the way to do that is, Shiji, did you get what pattern over here is?
Yeah.
Yeah. But my point is, so the pattern, right? I didn't understand the pattern when I looked at the question, but the point I want to make is, how would you solve it? Sue, you want to solve this?
Yeah.
You got the point, right? Like what the pattern
I
is?
got it, Ankur. So for each node, basically we are able to calculate a number based on the root node that we have started with. So which we will make it as a key, and we can add all the values or the nodes against it as the values, so that we'll have the lists against that number.
Exactly. So let's say we have a dictionary.
Yeah.
Let's say this is a hash map, and initially you have your queue. This is what you're saying, right? You start from your root and you give it 0.
Yeah.
And then when you do while loop, you extract node, and let's say this is some level. You extract from your queue, and if node dot left, so basically if it is a left,
yeah, we'll add that left and level plus 1.
Yeah, left and level plus 1. And if it is right, you just add right and you add only level.
Yeah.
Right? So CG, is this making sense? So remember, so when we were calculating height or the depth, we were adding the root and we were adding this one. Similarly, we are doing the same thing over here. We are adding node. We are extracting from the queue 2 things. Dot pop 0. We are extracting 2 things. We are doing node dot if node dot left. We are appending to the queue only the left node and level plus 1. And if node dot right, we are appending right and only the level. Is that clear? And also when we extract this one, right, the dictionary we added, we will just do dictionary of level dot append node. So at the end, we'll have a dictionary which will have 0 followed by list. Similarly, we'll have 1, a list, and we'll have a 2 and a list. And you just and then you return whatever you want, the interviewer wants. Are you getting this? What we did?
I got it, Ankur.
Yeah, and CG.
Yeah, I got the first one. If there is a left node, we will add the left and add a level plus 1. If it is right.
If it is right. If it is, sorry for all my crap handwriting. If it is right, so this is what we said, right? The pattern. For every node, if we go right, we add the same number. But if we are
Okay.
going left, we are appending one number higher.
Okay, got it.
That is what we are doing here. And then when we are extracting this, we are also putting into the dictionary level equal to dictionary level dot append node that value. So eventually at the end you'll have this dictionary,
Okay.
and then you return whatever the interview want. Okay.
Yeah, I'll do this one myself after the class. Then I'll.
Yes, yeah, I'll see the recording. Just see all this, how we are doing. This is something that has to, like, you should be able to do this question in like one. If you know the pattern, you should be able to do this question in like max 10 minutes, like code it.
Ankur, can you give me the code link for this? So I'll try to code it.
I don't know if there's a. I'll give you later after the session. I'll send you. I'll give you the.
Okay.
I'll give you the link.
Yeah.
Okay.
Yeah.
Okay. Now there's one more question. The last question of today.
Okay.
Okay. And this is a question that I got in my Facebook on that, and I hope people from Facebook are not seeing this. Okay. Like, I don't give anything about this.
Yeah,
okay?
make
So,
your YouTube channel a private group, Ankur, so that only.
I don't think anyone is even going to see my YouTube channel. I'll make it private. I'll see.
Yeah.
They won't do anything anyway.
Mm,
They
the
don't have so much of money to.
Yeah, the people who want to look at the YouTube, they just want the answers. They won't spend time. They just want the answer in 5 minutes.
Yeah, that's true. But we want to be on a safe side.
No, okay, I'll make it private. Or I won't even add it. I won't even add the session maybe. Or maybe I'll upload the video to.
Yeah, maybe the system design sessions, or maybe upload, keep them for a couple of weeks and then delete.
Yeah, I'll get a Zoom link.
Okay.
Which will actually expire in like 1 month. And I'll share that link with you guys.
Yeah.
I'll see if that works.
Yeah, for us, since we were in the class, we know where you talked, so we can go back and listen. But for the others, I don't know.
Yeah, they won't understand anything. Like, when I tried to go and look into my basics of system design session, I didn't watch it even for more than 1 minute. I said, it's so boring. Who will even look into it? So that's what. So, okay, let's see what is the other question. This was my Facebook content, and actually, okay. So the question is, yeah, and I got so I'll tell you what the problem also was, but I'll not tell you. I want you guys to solve it. Column, and I think if you have done a lot of lead code, you must have seen this question. And if you have, don't give the answer. Okay. So you are given a binary tree. Print the nodes column by column, and columns must be printed from left to right. And within each column, they have to be printed from top to bottom. Okay, so I'll give you the example.
Vertical traverses.
Yes. So if this is your tree, 3, 6, 3, 4, 5. This is 1. This is 2. Wait. This is 9. This is 7, 10, 0, and this is 8. So, have you done this?
I remember seeing this and the name called vertical order traversal, but I don't know the solution.
Okay. So, what I mean to say is, you need to return. Now column traversal means this is one column. This is one column.
17 will come under that column, right? 617 will be one column.
No. Really?
Yeah, 617 will be one column, like the right children of 3 and 2.
Wait, let me see one sec. Oh yes. So basically, this is one column.
Even 0 will come. Yeah, right.
Yes.
Yeah.
And
3 2 is one column. 5 9 is one column. 4 8 is one column. 10 is one column.
But why is 6 1 0 and 7 1 same column?
Which one? Can you? I think when you scroll up, you're seeing only half of the board.
Yes. Yeah.
Okay. What is the question?
Question is, why is 6107 in the same column?
Because they will, like, if you actually draw them in that order, they will be in the same column, right? They, like, it is like, say 6 is in one level, you have gone one to the left and then coming one to the right, so you'll end up in that same column. Like,
Okay.
think
And
it
if this was 2,
if there is,
this will
for
go to the
one-
next one.
yeah, right,
This will go into 482.
482. Yeah, right.
Okay. And okay. Wait 1 second. Somebody is calling me. Just one. Yes. Hello? Hello?
Hey, Ankur, we are here.
Okay.
Oh, you're talking to us?
Huh?
I think he's on the phone.
No, I'm done. Oh, sorry. I'm talking to you guys. My phone is
Yeah,
done.
yeah. We thought hello was for the
Okay.
other.
Okay. Sorry. Okay. Yeah. So I think Sue, she knows, she understood the pattern. Did Vijay and Shiji see?
Yeah, I did do this one actually. What exactly we had to do here is each.
No. Wait. Let Shiji also understand. Shiji, did you
Yeah.
understand? Like, what is column over here? Should I draw it? Well, what you guys are seeing is actually scrolling a bit slower than what, I mean, how I
Yeah,
scroll my app.
now we can see the full screen.
Okay, yeah, I can see. I'm also seeing my screen. Yeah. Did you understand what column here means? So basically, what you need to return is 5, 9, 3, 2, 6, 1, 0. अरे मैंने ही खोला है. This one. And you also have to make sure that the answer, right, it has to be 5, 9. It doesn't have to be, it shouldn't be 9, 5. Is that clear?
How about when you have this, like, 3, not 3 2, like 6107, 6017 or 6107 is okay.
Where say again?
So the middle
Can you
column,
have you wait? Have you opened this link separately on your? Can you draw what you're saying?
okay, here you have in the middle column, what do you have? 6107.
6, 1. Yeah, 6107. Yes.
6017 is also okay.
That is something. Wait. 6107. No. How will that be? Because one, we are going from left to right, right?
Mm-hmm.
You're going left to right. You click 5, 9 first, and then you see level 3, 2, and then you see this level, the 0th level. So basically, this is 0. Wait, 5, 9 is 0 level.
Yeah. No, in the
This is
other
1.
cases,
This is
there
2.
is a shift in level, but in the case of 6107, 1 and 0 are coming into the same column from the same level.
No, yeah, they are the same column, but you have to print
Do
them
it from
top to
left to
bottom and left to, top will come first, and then left
bottom
will
and
come
left
first.
to right. Okay.
Huh?
Yeah, top to bottom and left to right.
Yes.
Got it. Understood.
Yes. So I think my first question is, I think you already know. CJ, did you understand this one? I think, should I draw this again?
Yeah, this this is very confusing.
Okay, wait.
A smaller one should be helpful.
Okay, let's say I draw 6. So I just draw a small of this. Let's say 6, 3, 4. 10. This is 8. This is 0. This is 1. 5. 5 has 2. Is this clear, or can I draw? Can I complete the full? Let's say this is 7 and this is 9. Fine. This is a tree.
Okay.
Okay. And what you need to return to me is by column wise. Like you have to return to me. So there'll be columns like this. Okay. And I told you that this is my final answer. So this is my input and this is my output. Okay. So 5, 9 is one column. 3 and 2 is one column. 6, 1, 0, 7 is one column. 4, 8 and 10 is another column.
No, 4, 8 one column and 10 another column.
Yeah, 4, 8. Yeah. So I think, yeah, Sue, if you want to go ahead and solve it. I think you already know the pattern, right?
I just understood the pattern, of course. Don't
Oh,
know.
did you? Or did you? I thought you already knew the pattern. Like,
No, I understood the pattern. I don't know how to solve it. I can take care.
Okay, so can you say the pattern?
Yeah, so as you go left, you
Mhm.
decrease 1. As you go right, you increase 1.
So this
Yeah,
is what,
and
this is
you
1.
will do the same approach that you have done, like grouping all of the ones which have this value under the same
So
bucket.
this is -2. This is what? This is -1. This is 0, -1. This is -2. So that is why 6, 1, 0, 7, they come in the same column. So Shiji, did you get this?
Yeah. I understood what you wrote.
So
here.
basically, if you go left, you decrease by. So basically, we are doing column by column, right? So you start from 6. Column means if you, so let's start. If this is the, if you go to the left, we are going to the column which is before 6, right? So we do -1, and that's what it's saying, right? And if it is 6, and if you are going to the right, the column is the next column which is 1. And if we are at 4, if you go to the column after 4, it is 2. And if you go before 10, it should be in the column that comes before 10, which is 1.
Mhm.
That is all. It's a very basic pattern. Okay. My question is now, is it clear now, everyone? Vijay?
Yeah.
Okay. Now solve this.
See, what we have to do here is, right, once we have all these values, if we use the tree map, it is going to be in the sorting order. And then all the list, pretty much you will store it.
No, don't use tree map. Don't use tree map. Don't use tree map.
First, you are going to have all the, I mean, like a queue, you are going to use first step, okay? Based on the queue, the root will be 0, right? And then you have a node, right? That's like one object or one tuple, whatever you can say, right? Now you are building the structure. Now what happens is the root is 0, node, right? Now you are extracting that one, and then you can put into the hash map or something. In the hash map, what you can do is you can have a key is an integer, value will be value of that node value.
Yeah, so
right?
basically it's same as what we did before in the last question.
Exactly similar.
Yeah.
The only difference here is, in order to maintain the order, right, you can't achieve that one in the sorting order, right? Sorting order means you need to come up with all the numbers in the same sequence. You have to use the tree map so that everything will be sorted out. That's it.
So you're saying basically we have in our dictionary, we have -2 as a key, -1, we have 0, we have 1 and 2. And we have to make sure that when we are returning -2 first, -1, then 0, then 1, and then 2.
No, what? Yeah, you are right. See, -2, right? -2 is the key, right?
Yes.
The
Yes.
values will be all corresponding that one, right?
This is
In the
5 and
list.
9.
Yeah, your hash map will be, key will be integer.
Yes.
The value will be the list,
Yes.
list,
And
right?
this
List
will be
of
3 and
values.
2.
Yeah, like that you are keep adding everything. Then what happens is the parallelly once you reach end of level, right, then you can able to put into build a tree map so that everything will be in the sorting order. That's the only thing is
So
different.
are you saying, okay, is this clear to everyone?
No.
Who said no? Shiji?
Yeah.
So did you understand this one?
Yeah, that I
Diagonal?
understand. Yeah.
Right. So here also what we had was every node had some number associated with it.
Mhm.
Right? 0, right? You go to 0, you go to 14, it's 0. And if you go to left, it is 1. Then it is 1. If you go right, it remains the same. If you go to the left, it increases the 1.
Mhm.
Right? And then
Yeah.
when we were navigating, we were creating a dictionary. Right?
Yeah.
We were creating a dictionary with this key, and for this key we were appending this array. Similarly, for this key, as we were appending this one, and eventually we returned the result. So this is the array corresponding to the 0th key. This is for the first, and this is for the second, right? And in the this is exactly what we do in the next question also, column by column. But what Vijay says is we sort first. We need to return 0, then 1, then 2, right? So what he's saying, he sorts this array by the keys, because 0 comes first, right? So let's say dictionary, when you retrieve the keys, they come in random order. They can come in 2, 1, 0 also. All he's saying is we take out the keys, we sort the keys, then we iterate to the keys, and then we append into the array.
See, let me put it this way, right? Hash map or a dictionary will be like a key and value will be any order, right? It is not a sorted order. Now what we have to do is we build the dictionary, right? 0 means the column name, column number, sorry. Column number, what are the elements belongs to that, right? Now what we have to do is we just go through the loop, just like a for loop or whatever the while loop, right? Dictionary, you have to go through the each key set. You get the key, right? You get the key, and then you get the value of that key, means list of what belongs to that. What you can do is in Java or even any language, you have a tree map, right? Tree, what it does is it is going to order by default will be descending order, means small to big. Okay. What you have to do is you just blindly
No. So Vijay, don't use a tree map. What I'm saying is you cannot use a tree map. You don't use Java specific, like so Python doesn't have
Python doesn't have. Okay.
So don't use something which is related to Java.
Okay, then basically based on the column, you have to sort it out. You can in the Python, what you can do, you can use.
You get the keys and you sort the keys.
Okay.
Right. If you don't use tree map, that is what you will be end up doing, right? So is this clear?
Yeah.
So basically, we have to sort it by the key
based on the column. Yeah.
So is this clear to you?
Yeah, I understood the tree map approach. What were you saying, Ankur?
So what I'm saying is in Java, so Python doesn't have tree map. So basically what Vijay said is, if I don't know what, so basically I think what he's saying is he'll initialize this variable with a tree map.
Right.
No.
And tree map, if you add something, by default, all the keys are sorted.
No, not like that. No.
Yeah.
It is not like that. See, we build the dictionary, right? In the
then you convert it into a tree map.
Then what you have to do is you have to read each element, each key from the dictionary. Then after reading the key, then what you have to do is based on the whatever you need to build the tree map from there. First step will be you are going to have a queue, right? In the queue, what you are going to you are going to have a Java object or a Python object.
So basically we are not, Stu, what we're saying is we are not using this Java specific thing because Python doesn't have tree map. It only has dictionary, and the keys go in, but when they come out, they are in random order. Right. So what I'm saying is if say this is your dictionary, and let's say 0, and what was the answer? For 0 it was let's say this is -2, right? Or let's say this is 0, let's say this is 1, 2, 3, 4. You have -1. This is 0, 1, 2. Then you had, let's say you had 4. This is also 0, right? Let's
Yeah.
say you had all these keys randomly present, 0,
Mhm.
-1, you had this as 4, then you had 5, right?
Mhm.
But in the eventual answer, it has to be, first it has to be 0, 1, 2 because it's the least key. So 0, 1, 2, and then you'll have to go to 0 because it's the next higher key. So you'll put 1, 2, 3, 4. Then the next higher order is 4. Then you put 0. Then you put 6, 7, 8.
Ankur, so I understood the part where you are reading against each key, but within a key, how do we know that 0, 1, 2 will be the order?
Because you added, you are using it BFS style, right? You're doing from top to down. Top to down, you're doing BFS, right? When you're using Q, it is a
Uh-huh.
BFS, right? Level by level.
Okay,
That order will automatically come.
I see. Got it. Understood.
Each level you are putting into the list.
And then you're putting it in from left to right, so it'll automatically come back.
Exactly.
Yes.
Yeah.
Yeah.
Mhm.
Sriji, is that clear?
Yeah, it's clear. Yeah, and
Because
yeah,
so BFS, we are going from top to down. So when I said that column by column transversal, right? You have to. So when she asked, so Sue initially asked me what is the order for 6107. So here she said, so this is the order, right? 6107. So she asked me why is 1 before 0 and not 0 before first. That is because that is the order. This column comes before 0. And why is 6 before 7? Because 0 is at level 0 and we are going from top to down. They are going like this. Is it clear? Why 6 is before 7?
Yeah.
And since we are doing BFS, the order remains. Right?
Mhm.
Now, okay. So did you understand that we get the keys and then we do a sort? So this will become -1, 0, 4, and 5. And then we iterate through the keys. So for key in keys, which are sorted, first you get -1, you do result dot append dictionary of key, or sorry, this is plus equal to dictionary of key. This is clear. This is sorted. Clear?
Mhm.
Yeah.
I think, I mean, I'm writing the code. I mean, I'm sure it's not understandable. That is why you
Ankur?
guys have to understand.
How do you do sorting in Python?
Simple. You get the keys, right? So let's say this is a dictionary. You get keys equal to dict dot keys,
Correct.
and then you do sorted keys. This will return keys will be now this. So whatever this sorted keys will return, keys will be sorted.
Oh, basically you are sorting the keys. Okay.
So or you can do for key in sorted keys.
Okay. Okay. What is that? Sorted is the method. The
Yes.
function is available.
Yes.
Okay. Okay.
You
It
don't
is a
have to
part
import
of
anything.
dictionary.
Huh?
Part of the dictionary. Sorted.
No. It's by default. It's there in the kernel. You don't have to import anything.
Yeah, even for arrays also it will work.
Yes.
Sorted.
So
Okay,
keys is your
okay.
array, right?
Okay.
So this
Okay.
is dict.keys.
Got it. You already have a keys. You're just sorting the keys. Makes sense.
Yes. Fine, Siji. But there's one. Fine.
Yeah.
So 2 pointers. You don't even have to sort this. Basically, when you're iterating, just find the minimum column. Right? As you're going, you know the minimum column is -2, and every column will be bigger than -2. So all you do is, and you also know what your maximum is. Let's say when you're traversing, you maintain 2 variables, which is the low call. You also see high call. You maintain these two, right? So let's say this is -2 and let's say this is 3. So all you do is you iterate from -2 to 3. So now you don't even have to sort, because what comes after -2? -1, right? Then 0, then 1, then 2, then 3. So now you don't even have to do any sorting. So the sorting, you don't have to use then sort. Is that clear? Did I go very fast?
Yeah, this is one more problem people used to ask actually.
Say again.
This is one of the problem. I remember, I don't know, Facebook or somewhere people used to ask this one. in the phone
But
interview.
did you guys, Sue and Shiji, understand what I did, how I removed sorted?
I didn't understand that low and high
No,
column.
so basically, what is sorted doing? Why am I sorting?
You
Why
have to
am I
get
sorting?
that order of the result needs that to be in sorted order. So we are
Of the keys,
sorting.
right?
Yeah.
Yes. So let's say when I'm Sue, did you understand how I removed sorted? What is low key and the high key? Or the low call and the high call?
Sorry, I did not follow that.
Okay. So let's say this is my 0, right?
This part I understood. I didn't just follow that last part where you were. I thought you were explaining sorting in Python, and I like.
No. So
some
you
other-
understand why I did sorted,
Yeah. That part I understood.
right?
Sorted. I understood. Why this low call and
Okay.
high?
Now what is okay?
That
So what
part
is
I
sorted
understood,
doing?
Ankur.
Say again.
Yeah, I understood why it is needed.
Yes. Okay. But now see, now sorted means let's say I have n keys or k keys. Sorted means L log k log k, right? If there are
Yeah.
k keys, and if I do sorted, if I use the sorted function, it will be k log k. Oh, sorry. Yeah, k log k, right? Basically n log n.
So we are avoiding sorting here.
So to avoid sorting, yes. So basically, what we are doing by sorting, we are trying to find the order of the keys.
Mhm.
What I'm doing is, so when I'm doing processing, I start from 0. When I go to the leftmost, I know, let's say I'm at minus L. And when I go to the right, I know it's K,
Mhm.
right? All I need to do is iterate from minus L to K. That's it. I don't even have to now sort anything. As I'm iterating, I keep 2 pointers or 2 variables which are tracking the lowest column and the highest column. And at the end, I don't iterate. I don't do sorted. I just go from for I in range from minus L to K plus 1. That's it. And then in my result, I just append or plus equal to dict of I. That's it. So now sorting is not needed now. So since I'm doing range, it will go minus L, then minus L plus 1, minus L plus 2 up to K. Is this clear? No?
I didn't understand why this L came here. The sorting method I understood, but
Okay, let's say in my tree, right, my lowest column is minus 2. And my highest column, so this is the number of the column. So when we were here, this is the 0th column, this is the column minus 1, this is the column minus 2, right? This is 1 and this is 2. This is clear? We gave the numbers to the columns.
no, in the key we had 0, 1, 2 and the values, right?
Yes, so the one is your key. Similarly, 2
Yes.
is your key.
Okay, so we are changing the key itself to minus 1 and 1, 0 and all.
Yes. So here your key is minus 1. Here your key is minus 1. Here it is minus 2.
Oh, okay, got it.
Right? Because your root is 0. 2 you're getting.
Yeah.
So basically all I need to do is iterate from column minus 2 to 2, right?
Right.
Right? Okay. Now what were my column numbers? Minus 2, minus 1, 0, 1 and comma 2, right?
Mhm.
These are my columns, column keys.
Yeah.
Right? And when I did dictionary dot keys, this gave me some random element, let's say 2, 0, 1, minus 1 and minus 2, right? And when I did sorted, I got minus 2, minus 1, 0 and 1 and 2.
Mhm.
Fine. So this is my sorted. And after getting my sorted, I iterated through this. and then I did dict of whatever I do by iteration. Where am I? Where are you confused exactly?
We are not use sorting, right? We just have the keys as -1, 0, 1, 2. We just do a for loop and get the values.
No, but you have to be in the order, right? You'll have to first append these, the values related to -2, then -1, then 0, then 1, then 2. It cannot be random. It cannot be 2 first or 0 first and followed by 1, then -1, then -2. It has to be in an order from left to right.
Yeah, that we are doing the for loop, right, for the keys. Since the keys are -2, 1, 0, we are just doing a for loop from -2 to the end of the key.
Right? This is what you said, right, just now?
No, we don't need to sort, right?
Why?
We were avoiding the sorting, right?
By how?
That's what I thought.
Yes, that is what. So basically, when I'm doing my traversal, I know what is my lowest column. I know what is my highest column, right? I know -2 is my lowest. I know 2 is my highest. How? Because when I did my BFS, I was tracking that, right?
Yeah.
I was tracking that. So now all I know is I know what is my lowest
Yeah.
count. This is -2. What is my highest? It is
2.
3 or
3.
whatever. Okay, 2. Now what I do is I just do an iteration from, let's say,
Minus.
while minus. So basically, I just have to go from -2 to -1 to 0 to 1 to 2. Basically, from -2 to 2.
Yeah.
Right. So this way, I don't even have to sort. So let's say my I equal to -2, and let's say my j equal to 2. All I do is while I is less than j, less than or equal to j, and then I do I plus equal to 1 till it becomes j, and I keep adding it to my result. Still not clear?
Yeah, it's clear now.
So
Yeah, it's clear to me, Ankur.
okay, I'll give you the link. Go and code. Next time, just tell me if you answered it or not, or look at the solution, then you'll understand maybe.
Yeah, so this can be done only BFS way, is it not DFS?
Yes, exactly. So why cannot you do this in DFS?
Yeah, otherwise you won't get that order, right? Each
Yes.
row.
And that is so when during my F onsite, I was given the question. I started doing BFS, and then suddenly in the interview says, "Can we do?" I mean, before even I gave him the answer of BFS, he told me, "Can we do this DFS?" I said yes, and that is where I screwed up my onsite.
Yeah, since it is vertical, we first think that we have to do DFS.
Yes. Basically, this question I had never seen this before, and I jumped very fast into the answer. I thought, okay. I thought this is just column left to right, bottom to down. I didn't ask any of the questions. And this was 2 years back. I just said, okay, I can do DFS. And while doing DFS, and I took some, so I did DFS. He asked me, can we do this using DFS? I said yes. He said, okay, go ahead, solve it. I solved it. Then I took some examples. I figured out I cannot do DFS. And by that time, I said, oh, I cannot do DFS. And then I did BFS. I did BFS, the correct answer. But then I think that was they don't give feedback, right? So I think this was the reason I couldn't. I failed it on site.
Yeah, we were already confused, right? If that interviewer asks us about DFS, then we'll get more confused.
Yes. So that is why I wanted to ask this question. Right. So basically, before you even start solving the question, start writing the code. So Sue, this is something for you because you're giving onsite. When you see the question, try to understand even before seeing the code, right? I think look for the pattern. Try to ask. So you asked a lot of follow-up questions today. Like as soon as you saw the question, you asked, why is 1 before 0? Why can it be 0 before 1? Can it be 6? Why is that 7? So that was the correct. And if I had asked this question, I would have like passed my onsite. I would be wearing Facebook t-shirt today. But that was the problem. That is why I wanted to cover this question today.
Yeah.
And this question, so Facebook, right? They ask a lot of questions directly from LeetCode.
Would you be able to? I'm planning to schedule. 1 second.
Say again.
Yeah, so I have a Facebook recruiter. Reach out to me. If you can stop recording, we'll talk.
But tell them I need at least 3-4 months. So then they'll keep pushing.
Yeah, maybe we can stop the recording so that Sue can talk.
Oh,
you
wait,
got
wait.
me, Shiji.
Wait. I think anyway we are done with all the questions.